Exercise 2.2, question number 8. You are given a graph of y equals to 3x minus 2 to the power x plus 3. And the two roots are given in the graph that was shown to you. So you need to find a and b. How would you do this question? Is GC allowed? In this case, can we use GC? Yes, we can. Okay, because the question did not specify that they require the exact answer. So you can use GC, key in the equation in your GC. Now let's take a look at that. We can go to the graph function and then we key in the equation of 3x minus 2 to the power of x plus 3. Execute this and draw. Okay, so you roughly get the shape of the graph which was given to you already in the question. So to find the points of intersection, what must you do? Use what function? GSolve. Okay, so you use GSolve and you find the root. So this is the first root, which gives me the corresponding point A is negative 0.8098. So if you round off to 3 decimal places, what do you get? A is equals to negative 0.810. Okay, so let's go on to the next root, which is B. And B gives you 3.87. Okay, so we can from GC straight away. From GC, we get A equals to negative 0.810 to 3 decimal places, and B equals to 3.8. Now be very careful that you make sure you round off to the correct number of decimal places and round off correctly. Okay, that's for part 1 done. Okay, now let's look at part 2. Using the results in 1, show that if the sequence converges, it will converge to A or B. Now this is a standard type of question. Okay, you are given this recurrence relation. Xn plus 1 is equals to 1/3 2 to the power of xn minus 1, where n is greater than or equal to 1. Now very easy, what should we do in this case? If xn converges to L when n tends to infinity, what can we say about xn plus 1? Does it converge or not? And what is the limit? Okay, it converges to L as well when n approaches infinity. So looking at the equation, the above equation, okay, looking at the above equation, we have when n tends to infinity, okay, this is the same thing. When n tends to infinity, from this above equation that I highlight here, okay, when n tends to infinity, xn plus 1, okay, goes to L, and xn also goes to L. So we have L is equals to 1/3 2 to the power L minus 1. Okay, we have done this many times. So solving this equation, is it the same as solving the above equation? Let's take a look. For the above equation, just now we have already solved this. Okay, we have found the roots of this. Are these two exactly the same equations? Now let's try to do a little bit of conversion. If we multiply 3 throughout, we get 3L equals to 2 to the power L minus 3. Correct? So from here, if we manipulate the equation a little bit, we get 3L minus 2 to the power L plus 3 equals to 0. Are we solving exactly the same equations as part 1? Yes, we are. Indeed, we are. So we can get L is either equals to negative 0.810 or L is equals to 3.87. 8, 6, 8. And in this case, this is equals to A, and this is equals to B. We have already shown. Done. Now let's look at part 3. Okay, by considering xn minus xn plus 1, you need to show the two properties. Okay, so we get, you need to show this. Okay, want to show xn is greater than xn plus 1 if xn is between A and B. Now, you want to show this. So we need to consider, we need to move every term to one side of the equation. Xn minus xn plus 1 is greater than 0. In other words, you need to show this. Okay, if this. Okay, now let's start off with the left-hand side. Okay, now make sure you emphasize that this is what you want to show. Okay, so xn minus xn plus 1, what is this equals to? Okay, we are going to substitute in because previously we had one equation. We have the recurrence relation given to you, right? The highlighted equation. Can you see up here? This highlighted equation here. Okay, so we are going to substitute in xn plus 1, which is 1/3 to the power xn minus 1. Of course, we put a bracket around it. Okay, and now, what can you deduce from here? Okay, let's try to simplify the equation a little bit more. You get negative 1/3 to the power xn plus 1. Now, is this similar to the expression that was given to us earlier in the graph? Okay, every time for such questions, we try to use graphs to solve. So let's look at the previous equation that we have. The equation and the graph that was given to us is the one in red. Okay, the one circled in red. Now let's try to convert it to the similar form. You notice that from here, it is actually equals to 3 times, or rather 1/3 times of 3xn minus 2xn plus 3. Now what do I need to do this? Because I want to convert this part of the equation, this equation, to the same form as that was given to me in the question, so that I can make use of the graph to solve. Follow? Okay, so from here, looking at the graph, okay, let's go back to the question. Now our objective is to show that xn minus xn plus 1 is greater than 0. We want to show that this expression is greater than 0 if xn is between A and B. Now if we refer to the graph of what was given to us, the graph was like that. This is given in the question. A is here, B is here. Now if xn is between A and B, what do we notice about the y values? If the values of x is between A and B, the y values is positive. So this equation circled in red is greater than 0 if xn is between A and B. We can deduce this from the given graph. Okay, from the given graph. We can deduce from the given graph. So in this case, it's greater than 0 and we are done. So therefore, xn minus xn plus 1 is greater than 0. Implies that xn is greater than xn plus 1 when xn is between A and B. Now do the same for the other part, because you are required to show for the other part that xn is less than xn plus 1 if xn is less than A or xn greater than B. Okay, try that for yourself. Okay, that's all for this question. Done.